Hello everybody, welcome back to the second video for chapter 2. In this video I will teach you about dividers, prime numbers and the Hcf and the Lcm. There's a lot to do, so let's get started. We are going to start this paragraph with me showing you these numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. These numbers are pretty special. They are what we call prime numbers. All of these numbers can only be divided by two numbers, itself and 1. When talking about dividers, we only speak of natural numbers or integers. So no 2.5 or 3.333 repeating. So 5 can only be divided by 1 and 5. 11 can only be divided by 1 and 11. So we call these numbers prime numbers. 8 can be divided by 1, 2, 4 and 8. So 8 is not a prime number. There are a lot of prime numbers, but luckily you don't have to memorize them all. Any non-prime number can be factored into a product of primes. For example, 10, which is not a prime number, can be written as 2 times 5, which both are prime numbers. 12 can be written as 2 times 2 times 3, not 4 times 3, as 4 is a non-prime and can be written as 2 times 2. If you can't find the factors directly, don't worry, just try to find them step by step. Let's try that with 84. I can divide 84 by 2, so I get 2 times 42. And 42 can also be divided by 2. So I already have 2 times 2 times 21. 21 can be written as 7 times 3. That means I can write 84 as 2 times 2 times 7 times 3. But as I like my numbers sorted, I will write them down as 2 times 2 times 3 times 7. Understood? Perfect. On to the next part. Before we will be working with fractions in the next paragraph, I would like to teach you about factors and multiples. And with these, the Hcf and the Lcm. Don't worry, I will explain. When looking at 24, I can divide this number by 1, 2, 3, 4, 6, 8, 12 and 24. These numbers are called the factors of 24. The same can be done with 40. Its factors are 1, 2, 4, 5, 8, 10, 20 and 40. The highest common factor, or Hcf for short, is the biggest number I can divide both numbers by. As I can divide 24 and 40 both by 1, 2, 4 and 8, that means that 8 is the Hcf. We can write this with this notation. Next up is the Lcm, or lowest common multiple. A multiple is a number that's actually just the table of that particular number. So the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, etc. etc. The multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, etc. etc. We can see that both 3 and 5 have the 15 and 30 in common. That means that 15 is the lowest common multiple of 3 and 5. We write that with the use of this notation. Instead of writing all possible factors and multiples for the numbers in search of the Hcf and the Lcm, we can use a smart trick. This involves the use of the prime factors. Let's find the Hcf and the Lcm of 16 and 28. First, I will do it the old-fashioned way. We start by writing the factors of both numbers. For 16, that's 1, 2, 4, 8 and 16. 28 has 1, 2, 4, 7, 14 and 28. And then we see that 4 is the biggest common number, so the Hcf is 4. Then we write down the multiples of both numbers. For 16, we have 16, 32, 48, 64, etc., etc. For 28, we have 28, 56, 84, 112, etc., etc. We see here that 112 is the first one they have in common, so the lowest common multiple is 112. Now let's do the same but with the prime factors. 16 can be written as 2 times 2 times 2 times 2. 28 can be written as 2 times 2 times 7. For the Hcf, I multiply the common factors. As there are two 2's in common, I only have to do 2 times 2, which is 4, just like we had earlier. For the Lcm, I multiply the prime factors of 16 with any factor I haven't used of 28. So I do the 2 times 2 times 2 times 2 from 16, and I multiply that with the 7 of the 28 that I haven't used yet. And this also gives me 112. Most of the time the first method is quicker, but other times the factoring method is better, especially when the numbers are getting bigger. But luckily you can always pick the method you like best. And that's it for this video. In the next video I will help you with fractions. We will be simplifying fractions, adding and subtracting fractions, and even multiplying. I hope to see you next time. Bye bye!